The problem I'm going to be solving today is from section 3.4a and it's number 11. The problem is, use the lattice algorithm to perform each of the following addition problems. A, 4,358 plus 3,864, and B, 4,923 plus 9,897. When solving these problems, we have to remember these steps. Number 1, understand the problem. Number 2, devise a plan. Number 3, carry out the plan. And number 4, look back. So now, if we go back to what our question was, and our first step is, what is the question asking us? Understanding the problem. We have to know that for these two problems, A and B, we need to solve them with addition, but we're not going to do standard addition. We're going to use the lattice algorithm. Now we're going to do step 3, which is solve the problem, carry out the problem. So first we're going to start out by setting up the problem. So 4,358 plus 3,864, just like that. And now this looks like an ordinary addition problem, standard addition, but it isn't. This is when it gets a little tricky, and this is when you need to make sure that you understood the problem, make sure you know how to devise the problem. You need to know how to do the lattice algorithm. So when doing the lattice algorithm, you need to, well, one of the main things is you're going to set up a box that looks like this. And now we're going to do the sections of the box. So with the sections, how it works is we're going to make as many rows as we need. So each row is a place value. And now this is the part that makes it sort of different from any other problem. We need to split each of these place value boxes in half. Okay, so now we're going to start solving the problem. So we're just going to add straight down. 8 plus 4 is 12. So we're going to put the 1 up here and the 2 down here. 5 plus 6 is 11. The 1 up here, the 1 down here. 8 plus 3 is also 11. So we're going to put the 1 up here and the 1 down here. And then 4 plus 3 is 7. So we're going to put the 7 down here. And since we don't have a number in this place value, we're just going to put a 0. So now in order to get the answer to our problem, we need to add kind of diagonally. So 2, 1 plus 1, 2, 1 plus 1, 2, and 1 plus 7, 8. And then since that's a 0, we don't mess with it. So this is the answer we got using the lattice algorithm. Now, step 4 of our making sure that we're doing the problem right is to go back and check what we're doing. So now, in order to check what I did and make sure that I did everything right, I'm going to do standard addition and check to see if the answers are the same. 8 plus 4 is 12, carry the 1. 5 plus 6, 11, plus the 1 is 12, carry the 1. 8 plus 3 is 11, plus the 1 is 12, carry the 1. 4 plus 3 is 7, plus the 1 is 8. So we got the right answer, so now we are sure that our answer is correct. Another thing you could do is you could do this number, our answer, subtracted by one of these numbers, and if you get the other number that you're missing, you'll make sure that your answer is right. So an example of this would be 8,222, and we'll do 3,864. So to subtract, we need an extra 1. So we borrow 12 minus 4, 8. We don't have enough. We borrow 6 plus 11 minus 6 is 5. And then 1 minus 8, not enough, so we borrow. And then that would be 7. 11 minus 8 is 3. And then 7 minus 3 is 4. And this this answer that you get should be the other number that you never used. So we are sure that our answer is correct. Okay, so now we're going to solve letter B. So now let's start by setting up our problem. Now we're going to make our lattice box. And then we're going to split those in half. Now we're just going to add straight down. 7 plus 3 is 10. 9 plus 2 is 11. 9 plus 8 is 17. And 4 plus 9 is 13. Now all we have to do is add diagonally to get our answer. 0, 1 plus 1, 2, 1 plus 7, 8, 1 plus 3, 4 with the leftover 1. So our answer is 14,820. Now we're going to check our answer. We're going to look back and make sure that we did everything right. So this time I'm going to do it the subtraction way. So 14,820. And all we have to do is choose one of these. For this one, I'm going to choose 4,923. And if we did it right, our answer should be 9,897. 0 minus 3, not enough, so we borrow. 10 minus 3 is 7. 1 minus 2, not enough, so we have to borrow once again. 11 minus 2 is 9. 7 minus 9, we don't have enough, so we also have to borrow, so 3. 17 minus 9 is 8. And then 13 minus 4 is 9. So our answer equals what we thought it should, and our answer is correct. And that's everything. That's how you solve a problem using the lattice algorithm.